Right, so this is 2013 higher level shell structures question. We're going to cover part A, B and C in this. You probably won't get around to covering part D as such in this one. But we'll do A, part B and C. So basically it's a shell structures question, but unusually you could also treat it as a hyperbola question, right? As in the hyperboloid of revolution. So we look at how this compares to the 2019 question and the method that you could use. So I suppose the first thing to look at is when you look at it, you say, well, I'm not used to doing that question. But if you twist it this way, you'll actually see that that's the same as what we did last week. And also that this shape here, if this was the end view, that would be the same pretty much as you'll see that BD is a parabola. So all they've done is they've put the question a slightly different way around, right? So it's the same sort of shape as what we're doing. So the first thing I suppose just to note is, and then we'll read the question, is the scale. The scale is 1:2. So that means that you have to half all the measurements. So the first thing that I would do is put a dash through all the numbers and write the right numbers beside. Now I wrote that one with my marker, which is a little bit thick, so I'll try to write the rest of them with my pen. Okay, so that was 80. 180 becomes 90. 60 becomes 30. 90 becomes 45. 45 and 30. And 300 becomes 150. Okay, and we need space for an end view. I think it should be okay. Okay, I think it should be okay. So again, we just keep over to this side and it should fit in here. So the height of it is 80. So we come down about 100 and draw a ground line to start. So there's my XY line there to start. We'll keep in close to the side, and what we do is we just construct a rectangle for it. We won't actually put it into it yet. So I'm going to come in maybe, well, just in case, I'll just only come in 5 now. So we know that it's this width here, so we know it's 150 long. And we know that it's 80 high. Okay, so I'll bring that up. We could draw a centre line up the middle, but for the minute, I'm just going to leave that spot there for the elevation. Again, I think there's a good bit of space here, but just in case, I'm only going to come 10 mil apart. Let me just see. It's 90. Ah, yeah, should be fine. So I come 10 mil apart. Okay, and what I'll do is I'll draw out my rectangle again. I'll just use the pink line just for my projections. So it's coming down 90 mil. Okay. And what I'll do now is I'll do my space for my end view. Again, I'll use my pink lines for my projections. And we'll worry about centre lines and everything like that in a second. So. I'm not going to show the projection line across, I'm just leaving it on broad level just to keep a distance between them, but you could show a projection line across. So what I have there is a space for my plan, space for my front view, and space for my side view. So what I'm going to do is I'm going to read the question, I'm going to underline the keywords. And one other thing that you'll see is that typically they're going to give you the order in which to do the question if you read it carefully. So it says the graphic on the right shows an uplighter in the form of a hyperbolic paraboloid surface. So basically, what they mean by that is an uplighter is just a light fitting that you have on a wall that shines the light up the way. You don't really need to understand what it is in order to do it. It says we are showing the plan, elevation and end view of a similar uplighter. An isometric view is also shown. So an isometric view, in case you forgot from junior cert or in case you're new to the subject, an isometric view is basically just a 3D view. Okay, it's a type of 3D view. So an isometric view, you should have seen it in SolidWorks anyway. So the surface of the hyperbolic paraboloid is generated by translating the parabola ABC in a horizontal position downwards along the parabola BD. So the only difference there is the downward. So in other words, it's moving down along it rather than usually it says in an upright position. What we know there is basically there's a parabola ABC. So that means this here is a parabola. If I want to highlight that maybe in green so that I know what they're talking about. So we're told that that's a parabola by reading it, and we're told BD is a parabola. Okay, so just highlight that in green just so that we can see that. So B is the vertex of the parabola. Now this is important actually. B is the vertex of the parabola ABC. So we know that this is the vertex. Maybe if I highlight it in an orange there. And this one here is important as well. D is the vertex of this one. So B is not the vertex. So in other words, the parabola will be going this way if it was completed in full. So it is important to highlight where the vertex are. And then another thing just to be aware of in the question is they're very good with the current leaving cert questions in terms of giving them the order in which you should do them. So if they say draw the given plan first, project the given end view, and project the front elevation, chances are this is the way I should do it. I should do the plan first, should then project the end view, and I then should produce the front elevation. So for me, I'm happy enough that I would probably know that by looking at it, but I've attempted the questions a few times and I'd be used to looking at these questions. If you go in on the day exam and you're not sure where to start or what's the most logical order to start in, use the hints that they give you. So the given plan, then the end view, and then the front view. So the front view is the difficult one to figure out. Okay, so what we want to do is we want to make a parabola here. So we know that this ABC is a parabola. So half of 150 is 75. I'll draw a line up the middle. So it's 75 to divide by 5, which it divides evenly, which is 15. Now, again, I might use the division line method here just to prove I can do it. But for today, I'm not going to. Okay, we'll do the same on the other side. 15, 30, 45, 60. And we have 90 divided by 5. 9 and 9 is 18. So that's the split. 18, 36, 54, and 72. Okay. I'll just mark these over on this side also. So we'll mark out our vertex, which is B, and then we'll join our lines like so. So these will all be light. I'm using a light sort of bluish colour, bluey tealy colour. Now again, once you've one side done, you could use the mirror method, but it would be unusual. Typically you would use the same method for both sides just because you'd be used to doing it, but both are acceptable in case you'd see that in a solution. Often they might use it in a solution if they want to help show something else which you may see on the next part. Okay, so maybe I should have used it, as you'll see in a second, but I don't worry about that in a second. Okay, so we mark our numbers 1, 2, 3, 4, 1, 2, 3, 4. So you'll see I brought them pretty much to intersect. This one here I went a bit longer, but if they went down further, there's no problem with that. I just didn't because I'm so used to doing them at this stage. So 1, 2, 3, 4. Okay, so we'll sketch in our outline of said parabola. Okay, now it's 50-50 whether I do this bit now or whether I come back to it. I think I'll come back to it at the end. Okay, how to get this part. Okay, so we'll just take what we're used to doing. So what we want to do now, well, I suppose we could if we want to bring in, oh, they actually, by pure luck, they split where I want it. So that's my 30 line there. So I can heavy in them 2 bits there if I want. Okay, then light purple line will be useful in a few minutes, you'll see why. Okay, so we're going to now do our end view. So we can't, we have to project up D first anyway. Yes, okay, so we do have to project up D. I'm just trying to see, do they actually give us a hint? No, they don't as such. Right, so I suppose the first thing to do is explain what's this shape here. Okay, if you check, you will see that this shape here matches exactly this shape here. Okay, and that's what you would expect because this is your generating parabola, right? And if you continued on, it's the same parabola. So if I drew the full of it, the same parabola would exist down here, only for it's being cut off at a set distance. So it continues on, it would technically continue on up here, but it's been cut off at this, or at this width, I suppose, rather than the distance, at this width. So the easiest way to construct it is to just take this distance and step it off. I know that this point here is this far away, i.e. this point here is this far away. So therefore the point here is this far away, this point is this far away, this point here is this far away. Okay, as far as the junior cert graphics, this is the same as the translation. You're basically moving the exact same shape into a different position, but everything about it is exactly the same. Okay, so it's the same as your transformation geometry. So there's basically how I produced that. Now I was going to cover that afterwards, but I needed this point here in order to complete my end view. So I think I pretty much had to construct it there now. I don't think I could have got away with it. Maybe there's a different way of putting it up, I'm not sure. Okay, so I'm going to bring this bit over here. And that gives me my point D. Okay, so I'll just very briefly explain how I did there. If you see my purpler lines here, that's the same as just that light blue line there. And I know that every single point, that blue line there will be the same length, that blue line there will be the same length. It doesn't matter which point I pick. If I even pick them at random, they'll all be the exact same distance away. So once I know this distance here, I just use the same lines that I had. Technically I could have constructed extra ones if I wanted, but the handy thing with these is these are exact points. So therefore they should be exactly accurate. And I just stepped off the exact same distance, so literally it's everything. The other alternative I could have done, or could I have, well I'd still have to have found this point. I could then have constructed the exact same rectangle and drawn the full parabola, but obviously it would have went up into this view. So it might be a little bit confusing. But anyways, that's got me point D. I have point B. Okay, so I'm going to have to use the division line method for this side, because even, let's just see what this works out at one way. That to me measures 55 roughly, right? Again, the thickness of my mark might make a difference, but even if it did seem to measure 55 exactly on your page, it was found by bringing this point across. You aren't given that exact measurement, so you would be expected to use the division line method for that side. So I'm just trying to see which. It's D is the vertex, so I'm going to do the divisional line up here. Okay, it'll also keep it away from this side. Right, so I'm going to draw out a random line. I'm going to mark 5 equal parts. I picked 10 millimeters apart. I'm going to join the last one back to the end of the opposite line point that I want to split. And now I'm going to use sliding set squares to get that exact same angle and to bring down these splits here. Okay, I'll just heavy them a little bit. Okay. So again, D is my vertex. I'll use the green just to be somewhat different. So these will go here. Okay, so that's why it's important to understand where the vertex is, because it sort of changes. If it wouldn't be, say for example, these ones here joined to that one there. But again, if you made that mistake, it wouldn't be the end of the world. This is 80, so 80 divided by 5, 16, 16 and 32, 48 and 64. Move these across to meet it. And that should look similar to that. So if you did do it the wrong way around and you copied it, you should be able to reconstruct it. But I have my plan view done and I have my end view done, so I have A and B done there now. So what I'm asked to do is I'm asked to complete this part. Now, there are a few ways that you could do this, so I'm just going to show an alternative way. So the first way that you could do is you could do your normal method. So you could do that we were doing so far. So you could say, right, well, if I take a height here and I put that height onto this, I can then figure out a width and I can bring it up here and that will give me a point. Okay, so you could use the same method as we're used to doing, but there is an easier way, and that's sort of understanding a concept, and that's that if a parabola, which is our shape here, travels along an inverted parabola, which is our curve going this way, the resulting shape on the ground is a hyperbola, right? Now I don't think it says that in the, well, it sort of does here. It says the curves and elevation form a portion of a double hyperbola. Okay, so basically this is hyperbola, and that's a rule. It may not always tell you that, and I have a little graphic in the PowerPoint that shows that, so I'll have demonstrated that at the start of the lesson, so just in case you missed it. Right, but that's basically a rule. Now that only occurs if the parabola is inverted, so I'll just sketch it out. So if in the last question, I don't know if I have it handy, I don't think I do, I think it's on the back of this page. Right, but in the last question that we did, was sort of like this, and then it had a sloped angle, right? But this was a parabola. You were given an end view here of a parabola, and then you were shown that the curve went around like this, right? We could have also used the V1, V2 method that we're used to doing the hyperbola. Now we can't use it for this side, or if I look at this question here, we can't use that rule for this, because when I say an inverted parabola, this parabola is facing the wrong way. It would have to be going up the way. Okay, so I now know V1 and V2. So I'm going to go back to the method that I'm used to using for hyperbola. And that is, if I split this into 5 and I split this into 5 and join them to the opposite V's, I can basically figure it out. So the first thing I'm going to do, I should probably mark both sides at the same time, is just bring my splits that I've already figured out here over. Now, again, you could use the division line method for this part, right? But I'm not going to, and the reason I'm not going to is because this here, this distance here is 30 millimeters, because I'm given it. Okay, so 30 divided by 5 is 6. We're going to go 6, 12, 18, 24. So it is important that you put them up this side, obviously, because the vertex, the V1 and V2 are there. So it is important that you're well versed in this question, you know exactly where it's going. So again, these ones here will go to this vertex, our usual hyperbola construction method. And these ones here will go to this. So if you look back at your last question that we did that looked like this, you could have used this method. And for most of you, that would have made it simpler. But we want to get into the habit of figuring out how to figure out a width of a parabola once you had a height. Okay. Okay, and we'll do the same here. So maybe, I don't know, I'll use a different color because I'm just not convinced that some people might struggle to see that green. Again, these ones will go to here. As I probably mentioned to you before in class, it doesn't matter, once I have the points right, it doesn't matter if I get confused, because if I accidentally join these ones to here and these ones to here, you'd figure out they didn't meet. And then hopefully you'd understand that they must be the wrong way around. So as I said, I've never learned a rule in order to figure these out. Okay, I suppose I should probably have numbered them. 1, 2, 3, 4. 1, 2, 3, 4. So we're 1 and 1 cross getting a point, 2 and 2, 3 and 3, 4 and 4. And as a student said the last day, the difference in them is that in a hyperbola, all set of lines are angled. In a parabola, only one set of lines are angled. One of them are parallel to the edge. Okay, so that's the question done. We haven't part C covered here, or sorry, part D. We have A, B and C, which is what we want to get covered for today.